Now I want to simulate the circuit, a very simple circuit. So I have already opened the schematic file. You can see this is the name of the schematic file. You can choose this file, save as. The schematic file in LTspice is saved as with extension .asc. So you can change its name, maybe test circuit 1, test circuit 1a. So I can save this and it will be saved in the folder which was mentioned in this previous window. I can grab the resistor, for example. This is too big. What I can do is I can scroll and make it a little bit smaller, and then I'll place somewhere here. As you click here, you will get a copy of that if you move the mouse towards, if you hover the mouse around this R. So you will get another copy of the resistor R2, which is R2. You can use this if you want. Maybe I want to use it. I'll click again, and now if I want to rotate this, so I know the option for the key rotation is the key control R, but I want to do it from here. Just to show you this command, this is not stretch, I want to move it. This is rotate. So you click it and it will rotate, and then you can place here. So if I press the space bar, it will fit it in this window, and if I don't need any further resistor, I can right click and it will disappear. I can scroll again to make the circuit convenient for me, and if I left click, the whole schematic symbols will move around. Now I want to place a voltage source here. I'll just click a voltage source. It's obviously the left click, and I'll place it here. If you need another voltage source, you can bring it here, or right click or escape, it will disappear. Now I want to connect it. So if I use this wire or W and place my mouse here, I want to start from here. You can see the grid is changed. I click here, left click, and if I want to stop here and then move right, so you can see the alignment here. I'll just click here again, left click. I'll move over, will cross it, and then click here again. This is the left click, and click here, and then I want to move from take a turn here, so then click again, and then I can go here, click again, and then here. The LTspice will automatically, and then I have to do the right click. So the LTspice have automatically connected the components through this wire. Then I can click again. It's over here. Then right click, left click here, and then again click here, left click, and I have completed the circuit. I can press the space bar, it will zoom and fit to the window, but then I can again use the scroll to adjust it. As I told you that LTspice is based on nodal analysis, so you need a ground. So this is the ground. I place it and then I click right. Again take a wire here, just click this one, and this is the circuit. Then right click. If I click here now, left click, you can see nothing happens, but if I press it long, I can drag it right and left, and then leave it. You can see the blue color is a left click. So I left click and then keep on clicking and hold that, and then I can move the mouse to place it anywhere I want, and then leave it. If you want to simulate the circuit, you need some components values. So now I can't do this by clicking here because it will not select this resistor. So I have to go over here and I have to use this mode, move mode here, and when I click this one, you can see I can also show you the zoom version. You can see this icon with a plus sign here. If I click on this element, this element will be selected. This is the name of the resistor. This R is actually the value of the resistor, so I can click this and change the value. I can also click this resistor here if I want to maybe move it from here. Let's do it. If I click this resistor, you can see it will detach the resistor. So I'll do Control Z to undo this. And also the select option is also gone here. So I'll go again, click the move mode, and then you can see the cursor, and I'll click here, and I can move it right or left. So if I want to place here, it's here. Now I click this one, left click, and then here. Okay, this is fine. The value name of the resistor is one side, the value is on the other side, and just to make it according to your convenience, I just want to do this symmetrical here. The voltage source should be here, and its value should be over here. Now I right click, I have moved the components which I wanted. So now it's a normal cursor here. So if you want to change the values, so you place the cursor here, then its shape is changed from this plus to this, and then I right click here. You can see the resistor value you can change here. You don't need to write the units, it understands it is a resistor 10. Then I press enter, so this value is 10, maybe 10k. If you want to do 10k, right click on the value, you can also access the value here, k. Okay, this is right click here, 5k. Okay, I'm doing it from there, and then again right click just on the value. You can also right click on the component on the resistor, so then more options will come. You can select the predefined resistors according to the manufacturers, the values, the power, and the power which they can absorb, and their tolerances. And you can also select the parts here. So this is generic here, so I'll just click OK. Then I right click on this one, and I'll choose its value equal to 5k also. And I want to make this resistor, the voltage value, just clicking right here. I need the value equal to 10 volts. Okay. So the values are selected, the resistors are selected. So now we are finished with the circuit. Okay, this is not attached here. Then just have this here and right click. Now I want to set the simulation. So configure analysis. If I want to do only the DC simulations, I can, there's no need to write here how much simulation I want to run, because this is a DC circuit. At any time I can use any time here, so I'll use a small value, maybe 10 milliseconds, 10 milli. So the LTspice is case insensitive. If you write capital M or small m, it will consider milli, and then I click OK. You can see a directive has come here, it has appeared here, so I can just left click and then place it here. You can also access this directive by clicking this spice directive, and if you know that, you can directly write transient.tran and the stop time here. So you can also do that directly here, but I don't prefer that. I just use it whenever I want. So this is the transient simulation. So this is the simulation setting done by clicking this one, and since I want DC options only, I can say OK. This has to be this option must be clicked if you want only the DC values. But if I click if I use also the transient, it also tell me, it will show me the waveform. I can show you the difference. First I'll do without transient, so I'll just click on this one and remove the transient. So also I'll do again, right click, I'll do this one. This is the simulation setting. Now in simulation settings I'll use DC option and I'll say okay. You just have to activate this one, click it here, right click, and then simulation, this is default DC setting. So if I run the simulation, this will show me that a window will appear and this will show me the voltage at node 2 is 5 volts and voltage at node 1 is 10 volts. So I can guess from this the result here that node 1 is this one because this is 10 volts and this is zeros, and if I go up by 10, so I'm here, this is the 10 volts, this is the same node, so it's 10 volts. This is, I think, the third node is here, this is the node 2, this is 5 volts. And current in the resistor, you can see this is this is the sum, this must be noted that why we have the current in this circuit. For example, in current in 5 kilo ohm R3 and current in R2 must be same. Current in R3 is negative and current in R2 is positive. So this is the issue with the passive sign convention. I want to explain this one. So if I grab this resistor here, okay, I have to leave this. I'll do this. Okay, I'll just first I go out from the zoom and close. And the problem in that simulation was due to this particular reason, that if I grab a resistor here and right click, the PSpice by default assumes that this is plus, this is minus, and the current is flowing here. If I rotate it clockwise, like in this one, if I want to escape from this one, and if I click this resistor and I rotate it clockwise, like this one, there is a clockwise option here only, not the anti-clockwise. So if I place here and then right click, the positive terminal has moved in this direction and the negative in this direction, and this is the passive sign convention problem, that if I the 90-degree rotation makes this terminal positive over here and current in this direction, so that the current which is found here is in the opposite direction of this one. So that's why it is showing us negative current in our simulations. So to avoid that, you have to rotate this resistor 3 times. So I'll do it again. If I want to avoid that scenario, plus is the upper terminal. So if I rotate clockwise, I have this option, Shift R. So first I have to place it, and then right click, and then I rotate it, Control R, Control R. See, then Control R, then Control R. Now rotating it 3 times will place the positive terminal on this side and the negative terminal on this side, and then this current would be positive. You can check this one. Okay, I'll do this check for you. I'll first delete this resistor, all these are resistors, and I'll bring a new one and I'll rotate it, Control R first time, second time, third time. And I'll place it back here, right click, and then I'll use, okay, it's already selected, I'll just make it run. And what is happening here? Okay, I haven't used the value, so I'll use right click, 5K. Okay, and if you want to save it, you can save it, but I'll just run it. Now you can see that the current in the resistor R3, which is positive, and the current in R2 is also positive. So this was the this is so to speak the bug of LTspice that it it considers the element in this orientation. The upper terminal is positive and the lower is negative, and according to passive sign convention, the current will be moving from plus to minus or high to low. So to avoid that, you have to rotate it according to described here. So these are the settings if you want to simulate, you want to know the DC values. But sometimes it is not convenient from this particular results here. These are the operating points here. I'll just cross it and I'll just place my cursor here and I'll read it from this place here. So I'll just zoom in and this place is here. Here I will see, if I place here, you can see that in the bottom left here, it is telling me over here, you can read this in this bar here. This is node 1 and its operating point or the DC value is 10 volts. This is node 2 and this is 5 volts. Now this is no ground, the same node ground. This is still the ground. It is electrically extending a wire by a conductor does not change the node. So this is the same node, this ground. Every point on this is ground. You can see here. And every point on this line is on the same node. And the potential difference between the same node is actually 0 volts. So this is, there is no voltage drop here in this line here. This is the lump circuit model. And these were the three nodes. And if I place the cursor on the element, I can see the operating point, which is IR3, which is 1 milliampere, and it is also showing me the power is 5.002 milliwatt. Similarly for this one, and for the voltage source is supplying this is 2 milliampere. So 2 milli into 10 is actually 20 watts. So this is according to passive sign convention, that current is flowing from low to high. That's why the current direction is, current value is negative, and it is not according to the passive element. In passive element, current flows from high to low, from top to bottom, if this was a passive element. But since it's not a passive element, current is flowing from low to high, so the current has the opposite direction as was shown here, minus 2 milliampere. And that's why the power is negative. And negative power means dissipation is minus 20 watts is written, milliwatt here it is written, but this is plus 20 milliwatt dissipation. So that is how you can, in the textbook, you can, if you have resistive circuit, you can find their node you can do the nodal analysis directly from drawing the circuit in the schematic, and just click on the DC operating points and you can find the node voltages, and just placing your cursor after running the simulation from here, you can place your cursor here and you can see all the node voltages and you can verify your results.